Hello children, I am back, Vanashri ma'am, continuing with chemical bonding part 3. Okay, in the earlier two parts, I have taught you about electrovalent bond or ionic bond and about chemical bond. So, electrovalent bond, you have learned that it is formed by electrovalent bond, or the other name is ionic bond, is formed by actual transfer or transfer of, or even if you don't say actual, it is okay, by transfer of by transfer of electrons from one atom to another atom. Okay, another atom. Okay, and the compounds formed by the electrovalent bond, compounds formed are called by this bond, compounds formed by this bond are called ionic or electrovalent compounds. Okay, and how these are formed in detail I have explained. Then the other bond that I have taught you is covalent bond. Covalent bond is formed by sharing by sharing. Ionic bond is by transfer of electrons. This is by sharing of pair or pairs of electrons between atoms. Okay, so the molecules or the compounds formed by as a result of this covalent bond, the electrons or the compounds or the molecules formed as a result of covalent bond are called covalent compounds. Okay, I have given you enough number of examples of covalent compounds. Okay, double covalent bond, single covalent bond, triple covalent bond. Okay, now I will be teaching you polar covalent compounds or polar covalent compounds in which you have a polar covalent bond. Now what is it? Now let us consider example of water molecule. Okay, and this I have explained to you while how it is formed in while teaching covalent bond. Okay, so water molecule is formed by hydrogen molecule, so hydrogen atom sharing one electron with oxygen atom. Okay, with oxygen atom having oxygen atom having how many electrons? Oxygen atom's electronic configuration is 2 6. So 1 2 3 4 5 6. So 6 electrons are in the outermost orbit. So this way it shares one pair of electron with it forms a one covalent bond with hydrogen atom, and another it forms with another hydrogen atom. Okay, say this one. Okay, so like this it forms, this is the HOH molecule having two single bonds between oxygen and hydrogen atoms. Now in this hydrogen among these hydrogen and oxygen atoms, oxygen atom has high electron affinity for electrons, means it has a affinity for more stronger affinity for electrons as compared to hydrogen atom. That you can attribute the number of more protons present in the oxygen atom compared to hydrogen atom. So it has more tendency to electron atoms. So what happens is oxygen atoms pull the shared pair of electron towards itself. Okay, so it appears like this. Say hydrogen, both the atoms are pulled towards the oxygen atom like this. Okay, and this is the another pair. One second, I have to give little space. Now this is your oxygen atom. Okay, it has the 6 electrons like this. Okay, and so these shared pair of electrons are pulled towards oxygen because of its strong affinity for electrons. So as a result of this, electron cloud increases here. So here a partial negative charge, which we denote as minus delta, is developed because of the electron cloud here, and here a partial positive charge is developed. So this covalent compound, originally covalent compound, develops partial negative and partial positive charges. Okay, so such compounds are called polar covalent compounds, or the bond in this is called polar covalent bond. Okay, polar covalent compounds are nothing but covalent compounds. Covalent bond is in them, existing in them. Only thing is the shared pair of electrons pulled closer to one of the atoms which has higher electron affinity or more electron affinity than the other. As a result, a polarization of charge happens. Partial positive and partial negative charges are developed. Such compounds are called polar covalent compounds. I'll give you one more example. Consider the formation of hydrogen chloride. Okay, now you know hydrogen has 1 electron. Okay, chlorine atom has 7 electrons in its outermost orbit like this. Okay, now a covalent bond is formed between hydrogen and chlorine atom, resulting in the formation of hydrogen chloride. This is normal hydrogen chloride molecule, how it is formed, a covalent bond. Now again chlorine atom has more electron affinity than hydrogen atom. So as a result, the chlorine atom pulls the shared pair of electrons towards itself and develops partial charges like this. So this is the hydrogen atom. This is the chlorine atom. Okay, hydrogen atom shares one electron, and chlorine also shares So the shared pair of electrons are pulled closer to the chlorine atom, thereby developing a partial negative charge on this side and a partial positive charge. So this is another example of polar covalent compound. Okay, so polar covalent compounds, though they are covalent compounds, have slight charge separation, like similar to a ionic compound. In ionic compound, it is the ionic bond is formed between oppositely charged ions. But here, covalent compounds, but because of the electron affinity of one of the atoms, the shared pair of electron is pulled more closer towards one of the atoms, and it develops partial negative charge. Okay. Now we will learn about the third type of bond, that is coordinate bond, or sometimes it is also referred to as dative bond. Though the more commonly it is known as the coordinate bond. Okay, coordinate bond or dative bond. Very important. It has two examples in your scope, and each of them definitely comes alternatively every year in the boards. Okay, so coordinate bond or dative bond. Now first I will show you the example, then I will give you the definition, you will understand better. Okay, now let us take the example of formation of ammonium ion. Ammonium ion. Okay, ammonium ion, it is NH4 plus. It is different from ammonia. Ammonia is NH3. Ammonia is a NH3, which is a covalent compound. Ammonium ion is a radical or a ion, NH4 plus, with a charge, plus charge, unit positive charge. Now, ammonia ion, I have taught you how it is formed while teaching covalent compound. Okay, so the structure of ammonium compound is ammonia has 5 electrons in its outermost orbit because its electronic configuration is 2, 5. So now it combines with 3 hydrogen atoms. Okay, let me denote the electron given by hydrogen as red. Okay, so now the bonds, 3 single covalent bonds are formed. Okay, so this is the ammonia molecule with 3 single covalent bonds. Okay, ammonia molecule. But see here, this nitrogen atom in the ammonia molecule has 2 electrons extra. Okay, these are not shared, these are not utilized in the covalent bond. So these are called lone pair of electrons. These are called lone pair of, one second, these are called lone pair of electrons. Now wherever these such lone pair of electrons are present, those molecules usually take part in this coordinate bond. Now what happens when such a ammonia molecule comes in contact with a hydrogen ion? Okay, hydrogen ion is H plus, which does not have the any electron. It has lost its electron. It has only one proton. So H plus. Now what happens? When these two combine, this nitrogen shares this lone pair of electrons with hydrogen ion without the hydrogen ion contributing any electrons and forms ammonium ion. So here the shared pair of electrons between ammonia and hydrogen ion is contributed only by this ammonia molecule. So as I was telling you, this formation of ammonium ion is very important. Okay, so now this is the ammonia molecule which I have already discussed in covalent bond. So this electron pair which is extra is called lone pair of electron. So the hydrogen ion accepts this lone pair of electron forming NH4, that is NH4 plus or ammonium ion. So this leads to the formation of okay. Now here what is happening? This hydrogen atom, this hydrogen atom and this hydrogen atom, each one shared one electron. Okay, this is the nitrogen. They contributed one electron in this formation of ammonia molecule. Okay, but only this hydrogen ion did not contribute any electron pair but just accepted the lone pair of electrons, that thus attaining stability and forming NH4 plus ion, or that is ammonium NH4 plus ion. Okay, so this is the formation of ammonium ion. Okay, okay, so this is how they show. This dotted bond, this is the coordinate bond. Okay, this is the coordinate bond where the hydrogen ion does not contribute any electrons. Okay, so like here this hydrogen ion does not contribute any electron in the bond formation. So that is how now we can define the coordinate bond as coordinate bond is formed. How it is formed? By the sharing of electrons between two atoms or ions, between two atoms, and let us consider as atoms, in which both the in which both the shared pair of electrons are contributed by one atom and the other atom merely accepts the electrons. Okay. So here what happened? The shared pair of electrons are completely donated by the nitrogen atom, as I have shown you. Okay. So these are the shared pair of electrons, which are called lone pair of electrons. So these lone pair of electrons are shared between ammonia, nitrogen of the ammonia molecule and hydrogen ion, and thus leading to the formation of NH4 ion. Okay. Now this is very important example. The next important example is formation of hydronium ion. Out of these two, every year you get alternately either formation of ammonium ion or formation of hydronium ion. They are with the help of an electron dot diagram or with the help of a diagram, simply explain the formation of ammonium ion or explain the formation of hydronium ion. Okay. So now formation of hydronium ion. What is this hydronium ion? It is H3O plus. Okay, H3O plus ion. Now this is formed between water molecule and hydrogen ion. Okay. Now water molecule formation I have already discussed while discussing covalent bond. Okay. How is it formed? Between hydrogen, oxygen and hydrogen. Now hydrogen shares one electron and oxygen has 6 electrons in its outermost orbit. So in this way, let me write the O properly. Okay, this is the formation of water molecule. Okay, what is that? HOH. Two single covalent bonds are formed, right? So now oxygen has two pairs of lone pair of electrons. Can you see? This is one lone pair of electron and this is another lone pair of electron. Nitrogen in ammonium had only one lone pair of electron, whereas this in water oxygen has two lone pairs of electrons. So these are called lone pair of electrons. Okay. Now when this water molecule combines with again a hydrogen ion H plus, it leads to the formation of hydronium ion. Now in this the hydrogen ion does not contribute any electron. The oxygen of the water molecule only contributes for one pair of lone pair of electron for sharing. Okay. So this is also a coordinate bond formation where the pair of shared electrons are contributed entirely by one atom and the other atom or the ion just accepts the electrons and does not contribute any electron in the shared pair. Okay. So this leads to the formation of hydronium ion. This is the H plus ion and this is represented as H with one extra lone pair of electrons, and this coordinate bond is represented with this arrow mark. Similarly, in this also we will represent this as H, N, H. These are all three covalent bonds, and this is the coordinate bond. Okay, this arrow mark is the coordinate bond, right? Now similarly here also we have the hydronium ion. So as I told you, these are very important. Either hydronium ion or ammonium ion, one of them is definitely asked in the boards. Here I will show you the diagrammatic representation. Okay, this is how it is shown. Formation of hydronium ion. I hope the coordinate bond is clear. Now in this chapter you have only this, but only thing is you have another topic very important, that is comparison between the electrovalent compounds and covalent compounds. Okay, now the distinguish or differentiate between electrovalent compounds and covalent compounds. This is another important topic. So now electrovalent or ionic compounds, and these are covalent compounds. Now these ionic compounds or electrovalent compounds are usually solids. They exist in solid state, whereas covalent compounds covalent compounds are liquids or gases or soft solids. Okay, that is the difference in their state. Okay, then electrovalent compounds or covalent compounds are soluble in water but insoluble in organic solvents. So ionic compounds, this is regarding solubility. Ionic compounds are soluble in water but insoluble in organic solvents. Organic solvents means benzene. Okay, all these organic compounds, they are called organic solvents. Okay, so they are insoluble in organic solvents. Okay, whereas covalent compounds are usually They are insoluble in water but soluble in organic solvents. Okay, so covalent compounds are insoluble in water but soluble in organic solvents. Right, this is regarding solubility. Okay, then ionic compounds have high melting and boiling points. Ionic compounds have high melting point and boiling point, whereas covalent compounds have low melting point and boiling point. Covalent compounds have low melting point and boiling point. This is regarding their melting point and boiling points. Okay, then ionic compounds conduct electricity conduct electricity in aqueous solution. A Q U E O U S, aqueous solution means what? When a solid is dissolved in water, the solution formed is called aqueous solution. Aqueous solution or in molten state. What is meant by molten state? When a solid is melted, then we say it is in molten state. Now, covalent compounds, whereas, are not good conductors of electricity either in aqueous solution or in molten state. So, covalent compounds are bad conductors of electricity either in aqueous solution or in molten state. They are bad conductors of electricity. Okay, then now the last point of difference, ionic compounds are hard solids consisting of ions, whereas covalent compounds are molecules consisting of atoms. Okay, one more last point, ionic compounds are chemically very reactive. Okay, ionic compounds are chemically very reactive. Covalent compounds are not that reactive. Okay, covalent covalent compounds sorry, covalent compounds are not so reactive as ionic compounds. So this ends the chapter chemical bonding. Go through this, also go through the notes, and if you have any doubts you can ask me in my next class. Thank you children for paying attention, for watching. Have a nice time. Take care. God bless you.